Hey Ariel, let's take a look at this. Now this is no different than multiplying fractions, really. So if we just think about this in terms of fractions, if we had 3 halves times a fourth, well, what would we do? We would normally multiply the numerator, 3 times 1 is 3, multiply the denominator, which is going to be 8, and then reduce that if we can, right? That's all we're going to do here. But there's a bit of a shortcut, and the shortcut, let me come up with a better example, because this one actually came out to be in lowest terms. What if we did 5 fourths times, I don't know, 8 over 10, something like that, right? Well, there's another way. Yes, we could multiply. I could say that this is, 5 times 8 is 40 over 40, which equals 1. That's cool. We can still do that. But another way to do it is we could also kind of factor out this stuff. So I could call 10 5 times 2, and I could call 8 4 times 2. And then because I have a 5 in the numerator and a 5 in the denominator, they will divide out or cancel, right? It just equals 1, and we don't have to write the 1. Same with the 4's. So really what we're left with is 2 over 2, which still equals 1. We're going to do that play here with all of this kind of, crazy fractional with x's, business, and all that stuff. So let's do that first. The first step we should always do is just factor out what we can. Now here, I'm going to start with our first term, which is x minus 5. I'll just write that again. There's nothing we can factor out here. Over here, this is a binomial. We need to think about what the GCF is, which is 6, right? 6 divides into 6, and it divides into 24. So I'll just write the GCF. I'll start my brackets. And then remember, mentally, we just kind of divide each term by the GCF. Here, I'm left with an x plus 4, right? 24 divided by 6. We'll continue in this manner, and we'll factor everything else out. The GCF here is going to be 5. GCF here is going to be 5 as well. So again, I write 5, start my brackets, mentally kind of divide everything by 5. This is going to be x plus 4. And then down here, GCF again. And again, we mentally kind of divide everything by 5 and put the result in the brackets. Right? So everything is factored now. And this is kind of the same thing as with any kind of fraction. We can just reduce that down. Then let's take a look at what we can cancel, if anything. Our 5's cancel. Our x minus 5's cancel. Our x plus 4's cancel. So remember, all of this canceling really just makes a 1 somewhere. We rarely write that, but that's going to be our answer here. It's just going to simplify to 1 over 6. Now, again, the reason why I can cancel or divide, really, which is the same thing, is because all of this is fully factored. Everything now is a product. Everything is multiplying, so I can do the opposite operation. And when we think about BDMAS, BDMAS, right? Remember, we can do division or multiplication going left to right. And here, before I did all this division, let me just get rid of my blue marks for a sec so we can see what I did. I'll try to do it without deleting the whole thing. X. So remember, this was all multiplying. So yes, I could multiply the top, or I could divide. It doesn't matter in this case because as we go left to right, well, it's all really left to right. So in this way, it's more efficient. Factor everything completely first, cancel what you can, and then just multiply what's left. Keep in mind as well, we have some restrictions now. We have a variable in the denominator, right? We have an x here, and we have an x here. Remember that we don't want fractions over 0. We can have this. We could have like 0 over 1. Well, that equals 0. That's a number, a nice whole number. 1 over 0, or anything over 0, is undefined. Okay, so recall that we have to take a look at all of our exclusions. We have to look at what variables would lead us to a value of x. So take a look up here where everything's factored. We'll look at this x and this x. Now here, if I took this little expression x plus 4 and I said, well, that can't equal 0, and I just did some kind of one-step algebra, I would get x can't be negative 4. Right? So that can't happen. We can say x can be any value, but it can't be negative 4 because negative 4 plus 4 is 0. 0 times 6 is 0, so this whole thing goes to 0, which is undefined, and then we're multiplying this, and it's kind of like a chain reaction, right? Everything goes to 0. This one here, same deal. We could take this little expression, x minus 5, and we say that can't equal 0. Add 5 to both sides. with my rainbow pen, and x also can't be 5. Okay, so again now, that makes sense, I hope, right? 5 minus 5 would be 0, and again, this whole denominator deal would go to 0. So that's kind of our answer. Our answer is 1/6, we would say. We could express our answer. This whole thing will reduce to 1/6. And again, depending on the question, you might have to state your exclusions. So we would say x cannot be -4, comma, nor can it be 5. X can be any value except for those two values. I hope that helps. Please let me know if you have any other questions. Take care, Ariel.